All right, so we're back. Last time we talked about simplifying radicals. So we're going to look at some exponential equations, logarithmic equations today. So I have three examples to show you. We'll start with a basic one. So we have 2 times 6 to the xth power equals 22. So the first thing we're going to want to do here is divide by 2 on each side, which gives us this equation. 6 to the x equals 11 because 22 divided by 2, that's 11. So then we're going to have to use logarithms to get at this exponent. So say we did the natural log. Now we'll do a common log. 6 to the x equals the log of 11. Now remember, you can apply logs. You can do the same thing on both sides as long as you do, well, you have to do the same thing on both sides. So this is going to release this exponent to down here, which makes this be x times the log of 6, common log of 6, and that's still equal to the common log of 11. So I'm going to divide both sides by the log of 6 to solve for x. So x is going to be the log of 11 divided by the log of 6, which is the exact answer, but you'd probably type this into a calculator and come up with an expression, a simplification rather. And in my calculator, I had come up with 1.34. So if I substituted 1.34 into this, 2 times 6 to the 1.34 power, about, should equal 22. So there's the first example. Now let's look at another one that already has some logs in it. Okay, so here's our second example. It doesn't actually have logs in it yet, but we're going to put some logs in it in order to solve for x. So the first thing I want to do is, in this one, is let's move this term to the other side. Now to get at these exponents, I'll take the log of both sides. So the log, got new markers, they write better. So the log of 8 to the x, that's going to equal the log of 5 to the x plus 9. All right, so by doing this, we release these exponents to the front, so then we can deal with it and solve for the exponents. So x times the log of 8 equals x plus 9 times the log of 5. And this goes into parentheses here because it looks like I'm going to have to distribute x. I'm going to have to distribute log of 5 on x and 9 so that I can get my x's together on one side. So let's do that in this step. X times the log of 5, and then distribute it on the 9 plus 9 times the log of 5. So this term has an x in it, so I'm going to group it with this term on the left-hand side. So I'd have x log 8 minus x log 5 equals 9 log 5. All right, now notice I can take this x out. I can undistribute it, if you will. So that leaves us with the log of 8 minus the log of 5 inside here. And that equals 9 times the log of 5. So I have 2 common logs here, so I might want to simplify that as the common log of 8 divided by 5. So let's do that. I'll move up here. The log, well, it's x times the log of 8 divided by 5, and that equals what we had over here, 9 times common log of 5. So now I can solve for x if I divide both sides by the log of 8/5. So x is going to equal 9 times the log of 5 divided by the log of 8/5. And I previously typed this into my calculator, so let me get you the decimal approximation. It's about 30.82 in our pre-calculus classes. We usually go to 2 decimal places unless they say to go to more. But 30.82, so that means this, if it's substituted way back up in the beginning for x, should make an equation that's true. So, and it does. I checked it, so I'm just trying to show you how to get the x in these equations that require logarithms. So we're going to look at one more, and this one uses some natural logs, because sometimes people get confused with natural logs. But a natural log, instead of log base 10, is just log base e, but we write natural log. So let's do that now. Okay, so here's a third and final example. Notice it has Euler's constant in here, so that means we're going to be using the natural log function. But first I have to get the term with the x in it that I'm solving for by itself. So I'm going to start by subtracting 10 on each side. So that would leave me with negative 2e to the 5 minus 3x equals negative 6. All right? So now the term with the x in it is being multiplied by negative 2, so we're going to divide by negative 2 on each side. So that will get it closer for us. Negative 6 divided by negative 2 is 3. And then I'm going to, I should probably switch colors up here since I have new ones. So I would end up taking the natural log on both sides of this equation. So natural log of both sides of the equation gives me the natural log of e to the exponent. That releases our exponent times, I'll write it out. The natural log of e is going to go to 1, right? It's like saying the natural log or common log of 10. So natural log of e equals the natural log of 3. So we'll leave that there. So this, again, remember, that's going to go to 1, right? So it's just 1 times 5 minus 3x. 5 minus 3x equals the natural log of 3. See, we want to get at the x here, so I have to get rid of this 5. So I'm going to subtract 5 on each side. So negative 3x equals, no, doesn't really matter how we write it. You could write the natural log of 3 minus 5, which would be fine. But then we're going to divide both sides by negative 3. So that's a negative 5 plus natural log of 3 divided by negative 3. And again, that's the exact answer, okay, exact answer. But most of your textbooks are going to say round it to a certain number of decimals, which I did, and I came up with about 1.3. So there is a problem that requires the use of the natural log. Would you have to use a natural log on that? Think about that and let me know in the comments down below what you think about that. So friends, there you have it. 3 examples that require the use of logarithms in order to solve. Whenever you have an exponential equation, it requires the use of a logarithm. Either common log, natural log, sometimes some other base log, but you have to use a log in order to solve an exponential equation. So if you got some value out of this, consider hitting the like button, maybe even subscribing. Comment down below and share with somebody who you think might benefit from this. School is starting. My school starts tomorrow is our first day of class. So I'm going to be making a lot more of these videos. So please stay tuned.